In this lesson, we'll be looking at factorizing, which is the reverse of expanding brackets or multiplying out brackets. So we have a list of criteria here, and basically it goes through what you might do. So for instance, taking out the biggest number that goes into the terms, the highest common factor, but also looking at maybe shared variables and constants and other things too. So for each letter, in that case variable or constant or exponents too, in terms of the highest power, just be checking and seeing what you have in each part. Open the brackets, as we said, and you can also of course check your answer. You can check your answer for any of these and basically work it backwards. So instead of factorizing, expand the brackets, as you can see with a little example on screen there. Okay, let's get started. So a few basic ones. Factorizing the first one here, we have 3x squared plus 6x. So what do they share? Well, put our A first. Okay, so they share 3. 3 goes into 6 as well. 3x. And I think we just have an x there, so 3x times x is x squared, 3x squared, plus our sign there, 2. That's it pretty much. So if you were to check it, you would just go 3x times x and 3x times plus 2 to make sure. That should be generally known already. So we'll just keep moving on, and we have a few extra parts here, maybe an exponent. So what goes into 8 and 2? So we have our 2. So 2 times what? 2 times 4 for that one. We'll get to that. X and y, they both share an x and a y. Is there any extra parts? There could be an x squared or y squared. Not in this particular case, they don't share it. So whatever they share goes on outside. So 4x. We have our x squared, and we have an extra y squared for the second part. And again, checking it back, always check it back, that it multiplies out to get that. Okay, all right. In lower secondary, so this is for lower secondary mostly, you'll have a difference of 2 squares introduced. It won't get too complicated, like you may have in the GCSE or in A level, where you have to kind of just know them anyway. There's an example there with the rule, so let's just go through this to see how it works. So we'll see the first one's x squared minus n squared. Let's just write that out. And what that means is that you're doing the double brackets, essentially, that you would have done in a previous class on expanding brackets. And you'll end up with x plus n, x minus n. It might look a little bit odd to first check it, but if you just actually do the FOIL method as we did, first, outside, inside, and last, and you multiply it all out, you will see that you would get this. X squared plus xn minus xn minus n squared, and just to cancel them out, plus xn minus xn cancel out, and that's essentially what happens here. They cancel out those two middle variable terms. Okay, so the second one here, you can possibly see it by now if you can understand that first example. So what times what, almost in a sense, when you just have a constant. So we have our x and our x times x is x squared, and just without even doing the calculation, just knowing the rule, you might be able to see that that's the answer. You could have the positive or the negative sign in the first or second, it doesn't matter. Okay, and the rule is here as well, just above that box. Let's do a few more. First one, x squared minus 1, not particularly difficult, just looks a little off maybe. I can see how students might just get a little bit confused, but just think it's just the same thing. The second one has a little bit extra. So what we're talking about here actually is perfect squares. Just think of the normal square numbers that you know probably. 4, 9, 20, 16, 25, 36, 49. You just need to maybe see to check that they are a part of the question. Like in this case, we've 9 and 16, and we've a P and Q there as well. But they will be treated. The exponents are the variable, but the exponent will be treated just like we had previously. So what we actually end up with is 3P minus 4Q. And I'll just change that to a plus to be consistent. So you can be plus or minus whatever order. And essentially that's exactly the same as what you've been doing. Just a little bit extra in terms of multiples there. And part C will be the same. So if you come across a question like this, have a think. Okay, 3, so 3 goes outside. 75 is not actually a perfect square. So there's something else going on. So what you actually do is you factorize first. There might be a little bit of trial and error with this kind of question. And you'll see it's 25. 3 times 25. And from there, you may be able to see what we just did with the square. So we've x plus 5y. So a little bit extra there as well. X minus 5y. So x squared minus 25y squared would be the part there, because the plus 5xy and the minus 5xy would cancel out in the center. So that's essentially what these are. And I think that's about as far as you'll get in checkpoint, Cambridge checkpoint, or lower secondary grade 7, 8. And this is not so much a challenge for anyone in grade 9 and 10, but just to see how this comes together, we will factorize this rational fraction. Okay, x squared minus 36, from what we just did, x plus 6, x minus 6, with our perfect square. I'll do a little line with this one actually, just to make it look nice. There we go. And a little bit different on the base here, on the denominator. Just 5x and plus 30. There's no variable on the 30, so we just placed a 5 outside, because that's the only thing they share. So 5 times 6. And of course you might see now that x plus 6 divided by x plus 6 is 1. So our answer here is x minus 6 over 5. And that was factorizing from fairly basic stuff with the rules set out to the difference of two squares, which is important just to recognize in lower secondary, and a few extra harder questions there with a few tricks. And that's factorizing in algebra.